What do you mean by this? If you see, this is basically a 5-digit number. It is a 5-digit number. And in this 5-digit number, we are having 3 5s. Right? Like, in another word, we can say, let us say another example, say 75557. This is 6-digit number. And in 6-digit number, we are having 4 5s. Right? So if I say a number is of this kind, if we say a number is of 100 digit, so in that case, there will be 98 5s in between, and the number will start with 7 and end with 7. That's exactly what they have said in the first 2 lines of this problem. They have said 7, 5, 5, and this thing goes on 5, 7. Here, there are R5s. Okay, and we can clearly see that it is a R plus 12th digit number. Is it clear? This is the definition of the number they have given to us. Now, an additional information has been given that AC is 7, 7. Now, if you observe the last number given in this series, we are having 98 5s. So, if there are 98 5s, we can easily say that it is a 100-digit number. Is it clear? It's a 100-digit number. Now, if this is your S, we have been said another information given that S is written as this number is given in which we are having 99 5s in between, and the starting number is 7 and the ending digit is 7. That is, it is a 101 digit number. Plus m whole divided by n. Your S has been expressed in this way, where m and n are natural numbers, both are less than 3000. So the question is, you have to find out what is m plus n. That's the question. So what I will suggest you, please give a pause to this video right now and try this sum by your own. If you cannot do, come to this solution and check it.
5, 4, 3, 2, 1, 0.
So now let us start this problem. I will start from the given series which is given to us, which is S. Now, the second term of this series, it contains 1 5. The third term contains 2 5s. Means the series, the fourth term will definitely contain 3 5s. That is, when the term containing R5s, then it is the R plus 1th term of that series. So if we see the last term of S, we will find that there are 98 5s. It means this is our 99th term. Is this much clear to all? This is our 99th term. So to find out this series, the sum of this series, we will try to find out, we will generalize the nth term of this series. So let me write what is the rth term of this series. R is the general term. It will have so it will contain r minus 1 number of 5s. So we can write this number like 7 into 10 to the power r plus 5 into 10 to the power r minus 1, and this thing will go on. So 5 into 10 plus 7. This is how we have represented the rth term of this series. Now let me combine this one and this one. And if we take 5 into 10 common from this series, so we are having is it clear? Let it be as it is. This one is in GP, whose first term is 1, common ratio is 10, and the number of terms is r minus 1. Therefore, we can write this thing as I have applied the sum of geometric series. So we are having basically so this is our rth term. Not a big deal. This is very normal to us. Now, to find out S, I have to take sigma on both sides, where r will start from 1 and it will go till 99, because as I have already mentioned that your S, the series S contains 99 terms. Therefore, your S is sigma tr, where r starts from 1 till 99, which is same as is it clear? Let me simplify a little bit. Ten to the power r plus 7 over here. This can be written as 10 to the power r divided by 10 minus 1 inside the brackets. So we are having, it is coming like 7 plus, if I multiply this one, if I multiply this 2, we are going to have 5 over 9, 10 to the power r. So let me keep it in one bracket, and we are left with 7 minus 50 over 9. So we are basically having 68 over 9 into 10 to the power r plus 13 over 9. So if we separate the sigmas, so let me take the constant outside the sigma. And this will be 13 over 9 written 99 times. So it will be into 99. So that gives us, this is basically our GP series whose first term is 10 and the common ratio is 10 and the total number of terms are 99. Therefore, we can write this thing as, so we are basically getting 10 minus 1 is 9, so it will come here and it will become 81 into 10 to the power 99 minus 1 plus 13 into 11, 143. Is it clear? So this is what we got our S. This we got our S. Is it clear? Okay, now the additional information that is given to us is S equals to, now can you please tell me what is this? This is your 100th term. This is your 100th term. We got the rth term is this, which is same as after simplification is this. So this is your rth term. Let me just write it here. The rth term is it clear? This is your rth term. And in the additional information, we have been given this term is the 100th term. So what is the 100th term? Is it clear? This is my 100th term. Okay. So now what we have to do, we have to simply convert this S in terms of T100. That's exactly what they have given in this additional information. And from there, we will compare M and N to get its value. As simple as that. Okay, now let me just try to convert this S in terms of T100. So we can write this thing as, it is 10 to the power 99 in S, so it can be written as 10 to the power 100 by 10. Why I am doing this? Because I want to convert this S in terms of T100. That's the reason. So we are getting okay. So we can write this as, I will work on this afterwards. Now let me replace 68 over 9 into 10 to the power 100, and outside we are having 1 over 9 plus 143, 680 by 81. Why I have written in this way? Because I want to convert this in terms of T100. So this part can be replaced from this equation in this way. Is it clear? So now we can write so if we first simplify this 2, we are getting 143 is there. So it will get cancelled with 9. Now if I take LCM, This is my S. 1287 minus 77. So that gives us T100 plus 1210 divided by 9, which is your S. And now if we compare this with which is given to us, we got M is 1210 and N is 9. Therefore, M plus N will be 1219. And that's your answer for this question. Is it clear to all? It's a unit sum, very nice problem, which actually came in JEE Advanced 2023. So I hope you people have all understood. So see you in my next video very soon. In this question, we have been asked to solve for x. x निकालने के लिए बोला है, दो इक्वेशन दिया हुआ है. एक है 5 times fractional part of x equals to x plus greatest integer function of x. This is my first equation. और जो दूसरा इक्वेशन दिया हुआ है वो है greatest integer function of x minus the fractional part of x is equals to half. और ये जो ब्रैकेट्स है, ये ब्रैकेट स्पेशल फंक्शन रिप्रेजेंट कर रहे हैं. यहां पर देखो क्वेश्चन में सीधा सीधा लिखा हुआ है कि दिस इज द फ्रैक्शनल पार्ट फंक्शन एंड दिस इज द ग्रेटेस्ट इंटीजर फंक्शन. सो डोंट treat those brackets as your normal brackets. So क्या करें? इसको मुझे सॉल्व करना है, मतलब x का वैल्यू निकालना है. तुम लोग करो क्या, ये वीडियो को यहां पर पॉज करो और एक बार खुद से ये सम ट्राई करो. नहीं होगा फिर आ जाओ यहां पर, फिर वीडियो को ऑन करो और देखो इसका सॉल्यूशन. देखो मेरा जो फर्स्ट स्टेप होगा वो है कि यू हैव टू फाइंड अ रिलेशनशिप बिटवीन फ्रैक्शनल पार्ट ऑफ एक्स एंड बॉक्स एक्स. मतलब इक्वेशन में कहीं पर अगर देखो एक्स दिया हुआ है, सो उस एक्स को तुम कन्वर्ट करो इन टर्म्स ऑफ ग्रेटेस्ट इंटीजर फंक्शन एक्स एंड फ्रैक्शनल पार्ट ऑफ फंक्शन एक्स. मुझे पता है कि x इज नथिंग बट बॉक्स ऑफ x प्लस फ्रैक्शनल पार्ट ऑफ x. अभी मेरा जो पहला इक्वेशन है, इसको इस x को हम लोग रिप्लेस कर देंगे वही से फ्रैक्शनल पार्ट ऑफ x प्लस ग्रेटेस्ट इंटीजर फंक्शन x. सो मेरा जो इक्वेशन फॉर्म ले रहा है वो है 4 ऑफ फ्रैक्शनल पार्ट ऑफ x इक्वल्स टू 2 times बॉक्स x. ठीक है. अभी यहां से हम लोग लिख सकते हैं मेरा बॉक्स एक्स क्या है, इट इज 2 times फ्रैक्शनल पार्ट ऑफ एक्स. अभी इस रिलेशन को लेके हम लोग सेकेंड इक्वेशन में पुट करेंगे, बिकॉज मुझे निकालना क्या है, मुझे निकालना है एक्स का वैल्यू. और एक्स का वैल्यू अगर चाहिए तो मुझे ग्रेटेस्ट इंटीजर फंक्शन ऑफ एक्स चाहिए, at the same time fractional part of x चाहिए, right? Okay, so box x is 2 times fractional part of x. इसको तुम इस इक्वेशन में पुट करो, देखते हैं क्या आते हैं. 2 times fractional part of x minus fractional part of x is half. Yes or no? So अभी 2 times fractional part of x minus fractional part of x will give us only fractional part of x. मतलब यहां से मुझे डायरेक्टली मिल गया कि मेरा फ्रैक्शनल पार्ट ऑफ x जो है, मतलब जो x मेरा नंबर है, उस रियल नंबर का फ्रैक्शनल पार्ट क्या होगा, इट्स हाफ और 0.5. क्लियर हुआ? अभी फ्रैक्शनल पार्ट निकल गया. अभी मुझे चाहिए क्या, मुझे ग्रेटेस्ट इंटीजर पार्ट वाला फंक्शन चाहिए। मतलब x का जो इंटीग्रल पार्ट है वो क्या है मुझे निकालना है। वो हम निकालेंगे कैसे? दैट आई विल गेट फ्रॉम दिस इक्वेशन। कैसे? फ्रैक्शनल पार्ट ऑफ x तुम अगर पुट कर दोगे तो तुम्हारा बॉक्स x कितना आएगा? 2 टाइम्स 1/2। सो ये 2 कट जाएगा। सो मेरा बॉक्स x कितना आएगा? दैट इज द इंटीग्रल पार्ट ऑफ x। क्या आएगा? इट इज नथिंग बट 1। हो गया, बॉक्स x निकल गया, फ्रैक्शनल पार्ट ऑफ x निकल गया, मतलब मेरा x निकल गया। क्यों? मेरा x क्या होता है? बॉक्स x प्लस फ्रैक्शनल पार्ट ऑफ x। अभी बॉक्स x का प्लेस में तुम लिखो 1 और फ्रैक्शनल पार्ट ऑफ x का प्लेस में लिखो तुम हाफ। So it is coming to 3/2 or 1.5, whichever way you want, you can represent. Right? मतलब मेरा x का वैल्यू क्या आया? 3/2. So ये सब हमने क्या किया? क्या स्टेप मुझे याद रखना है? जो स्टेप मुझे याद रखना है, नंबर 1, अगर कहीं पर वहां पर तुम देखो इक्वेशन जो दिया हुआ है उसमें x है, उस x को तुम कन्वर्ट कर लो इन टर्म्स ऑफ integral part or the greatest integer part of x and the fractional part of x. By means of this formula, we know that any x is always written as box x plus fractional part of x. Is it clear? अभी अगर दोनों इक्वेशन दिया हुआ है तो वहां से तुम्हारा मेन टेंडेंसी होगा टू फाइंड आउट द फ्रैक्शनल पार्ट ऑफ x as well as your greatest integer part function of x. सो इंटीग्रल पार्ट ऑफ x निकल गया, फ्रैक्शनल पार्ट ऑफ x निकल गया, उसको तुम इस इक्वेशन में पुट करके x का वैल्यू निकाल दो। दैट एग्जैक्टली व्हाट दे वांट इन दिस क्वेश्चन। इज इट क्लियर? ओके, लेट अस मूव फॉर अनदर प्रॉब्लम। सी दिस सम। यहां पर बोला है फाइंड द नंबर ऑफ सॉल्यूशंस ऑफ द फॉलोइंग इनइक्वालिटी। और इनइक्वालिटी में दिया क्या हुआ है? 2 to the power 1 by sin square x2 into 3 to the power 1 by sin square x3, 4 to the power 1 by sin square x to the power 4, and this thing goes on till n to the power 1 by sin square xn. And this is less than equals to n factorial. अगर ये है तो कितना नंबर ऑफ सॉल्यूशंस आर पॉसिबल? दैट इज द क्वेश्चन। कितना नंबर ऑफ सॉल्यूशंस मतलब तुम्हारा जो x2 x3 x4 करते करते xn तक जो वेरिएबल्स है, ये कितना पेयर्स में वैल्यू ले सकता है? आर यू गेटिंग द पॉइंट? x2 x3 x4 xn ये कितना वेज से टोटल वैल्यूज ले सकता है? एंड दैट विल बी द सॉल्यूशन फॉर दिस इक्वेशन, आई एम सॉरी, इन इक्वेशन। सो करे कैसे? अगेन पॉज द वीडियो एंड ट्राई दिस सम बाय योर ओन। नहीं होगा वापस चले आओ वीडियो में। देखो बच्चों, यहां पर दिया हुआ है मेरा xi जो है वो क्या हो रहा है? वो लाई कर रहे 0 से 2 पाई के अंदर। 0 से 2 पाई के अंदर i क्या है? यहां पर i जो है वो स्टार्ट हो रहा है 2 3 4 करते करते जा रहा है n तक। इसका मतलब यह हुआ कि x2 x3 x4 टिल xn ये सब लाई कर रहे 0 से 2 पाई के अंदर। क्लियर? अभी यहां पर क्या करें? कैसे स्टार्ट करें? एक चीज देखो, मेरा जो साइन स्क्वायर xi है, अगर xi लाई कर रहे मतलब i कैन बी एनीथिंग, दैट इज x2 x3 x4 ऑल दोज वैल्यूज दे आर लाइंग बिटवीन 0 एंड 2 पाई। अगर 0 एंड 2 पाई के अंदर है तो साइन ऑफ xy इज लाइंग बिटवीन -1 and 1। क्या बोल रहे हैं हम? साइन ऑफ एक्स आई इज लाइंग बिटवीन -1 and 1. So मेरा sin square xi will lie between what? Sin square xi will lie between 0 से 1 के बीच में. क्लियर? लेकिन sin square xi हर एक केस में इन द गिवन क्वेश्चन वो डिनोमिनेटर में है, मतलब वो वैल्यू 0 नहीं ले सकता. राइट मतलब तुम्हारा जो साइन स्क्वायर एक्स आई है वो क्या वैल्यूज ले सकता है? 0 से 1 के बीच में कोई भी वैल्यू, 0 को छोड़ के. अच्छा, लेकिन सर इससे मेरा सॉल्यूशन कैसे आएगा? ओके, एक काम करते हैं, बोथ साइड्स हम लॉग लेते हैं टू द बेस ई. क्यों ऐसे? क्या? क्योंकि मुझे पावर में जो चीज है उसको नीचे में ले आना है, एंड द ओनली वे टू डू दैट इज टू टेक लॉग ऑन बोथ साइड्स. अगर हम बोथ साइड्स में लॉग लेते हैं और लॉग का प्रॉपर्टी यूज करते हैं, क्या प्रॉपर्टी? लॉग ए टू द पावर एन इज एन लॉग ए. ये प्रॉपर्टी अगर हम यूज करते हैं तो मेरा जो लेफ्ट हैंड साइड है इनइक्वालिटी का, उसमें क्या होगा? 1 बाई साइन स्क्वायर x2 log 2 base e. I am taking log on both sides to the base e plus 1 by sine square x3 log base 3. I'm sorry, log 3 base e plus 1 by sine square x4 ln 4, right? And this thing is going on. लास्ट में होगा 1 by sine square xn ln n. ओके, राइट हैंड साइड में देखो बच्चों क्या है? फैक्टोरियल n. फैक्टोरियल n का मतलब 1 into 2 into 3 into 4 into करते करते n तक जा रहा है. राइट नाउ इफ यू टेक log on both sides तो क्या मिलेगा? log 1 plus log 2 plus log 3 plus log 4, ऐसे करते करते जाएगा. log 1 होता है 0. सो हम लोग स्टार्ट करते हैं यहां पर लिखना ln 2 ln 3 ln 4 प्लस लास्ट टर्म क्या आएगा? ln n. फैक्टोरियल n को उसका डेफिनेशन वाइज हम लोग लिखा 1 into 2 into 3 into 4 into करते करते n तक. फिर हमने log लिया तो log ab का प्रॉपर्टी जो है log ab इज log a प्लस log b. सो इसको हमने प्लस फॉर्म से हर एक टर्म को लिख दिया. log 1 क्यों नहीं लिखा? बिकॉज log 1 इज 0. ओके, सबको तुम लेफ्ट हैंड साइड में लेके आओ. सो वी आर हैविंग 1 बाय साइन स्क्वायर x2 minus 1 into ln 2 plus 1 by sine square x3 minus 1 ln 3 sine square x4 minus 1 ln 4. और ऐसे करते करते जाएगा, जाके लास्ट टर्म जो आएगा 1 बाय साइन स्क्वायर xn minus 1 ln n is less than equals to 0. समझ में गया? सबको सब टर्म जो राइट हैंड साइड में था उसको लेफ्ट हैंड साइड में लेके आया और हमने ग्रुप बनाया ln 2 का साथ ln 2, ln 3 का साथ ln 3, ऐसा करके ग्रुप बना के हमने कॉमन लिया है. सो दिस थिंग इज कमिंग टू लेस देन इक्वल्स टू 0. ओके बच्चों, एक चीज देखो, अगर साइन स्क्वायर एक्स आई 0 से 1 के बीच में है, इसका मतलब ये तो पक्का हो गया कि 1 ओवर साइन स्क्वायर एक्स आई ये कहां से कहां तक बिलोंग करेगा? 1 से इंफिनिटी तक, 1 से इंफिनिटी तक लाई करेगा. यस, अगर साइन स्क्वायर एक्स आई, साइन स्क्वायर कोई एंगल का वैल्यू अगर 0 से 1 के बीच में है तो 1/sin² xi क्या होगा? एक से ज्यादा होगा, एक से ज्यादा होगा तो खत्म कहां पर होगा? जाएगा कितना दूर तक? इन्फिनिटी तक, कोई भी वैल्यू ले सकता है. ओके, सो नाउ इफ यू सी दिस इनइक्वालिटी, इफ यू सी दिस इनइक्वालिटी, if you see this inequality, you will find that your right hand side is 0. मतलब क्या बोला है? ये जो टर्म है लेफ्ट हैंड साइड में, जो भी मेरा टर्म है, ये क्या हो रहा है? 0 से छोटा या इक्वल्स टू 0. अभी देखो बच्चों, ln 2, ln 3, ln 4, ln n, ये तो ऑलवेज ग्रेटर देन 0. मतलब अगर ये ऑलवेज ग्रेटर देन 0 है, लेकिन मेरा आंसर क्या बोल रहा है? इट इज लेस देन इक्वल्स टू 0. इसका मतलब ये हुआ कि हर एक टर्म को अगर लेस देन 0 करना है तो हर एक टर्म को मुझे लेस देन 0 बनाना पड़ेगा. मतलब किस टर्म को? जैसे मानो 1/sin² x² -1, इसको मुझे 0 से छोटा बनाना पड़ेगा. अदरवाइज ये कैसा ये एक्सप्रेशन लेस देन 0 होगा? ln 2, ln 3, ln 4, ln n, these are all positive numbers, but your answer is less than 0. This whole expression is less than 0. ये less than 0 तभी होगा जब हर एक कोफिशिएंट ln 2, ln 3, ln 4 का जितना भी है सब तुम्हारा नेगेटिव होगा, राइट? बट ये तो पॉसिबल ही नहीं है. क्यों पॉसिबल नहीं है? बिकॉज तुमने बोला, हम लोग क्या देखा? 1/sin² xi, दिस इज ऑलवेज ग्रेटर देन इक्वल्स टू 1. और ये चीज अगर ग्रेटर देन इक्वल्स टू 1 हो जाए, मतलब एक चीज तो पक्का है कि ये एक्सप्रेशन कभी भी नेगेटिव नहीं हो सकता, कभी भी नेगेटिव हो नहीं सकता. तो कम से कम इसका वैल्यू क्या हो सकता है? इसका वैल्यू इज ऑलवेज ग्रेटर देन 0. और अगर ये सब का वैल्यू, इसका वैल्यू, इसका वैल्यू अगर सब ग्रेटर देन 0 हो गया तो ये तो जिंदगी में कभी लेस देन 0 नहीं होगा. तो लेस देन 0 होने के लिए मुझे ये जो टर्म्स है, ये टर्म को लेस देन 0 होना पड़ेगा. कम से कम एक को तो होना ही पड़ेगा, राइट? लेकिन ये कभी भी 0 से नीचे होगा नहीं. क्यों? बिकॉज 1/sin² xi इज ऑलवेज ग्रेटर देन इक्वल्स टू 1. सो इसका जो इस टोटल एक्सप्रेशन का जो मिनिमम वैल्यू हो सकता है वो है 0. वो है 0. अच्छा, मतलब अगर हम हर एक टर्म को इक्वल्स टू 0 ले लेते हैं, तब क्या यह पॉसिबल है? हर एक टर्म को अगर हम 0 ले लेते हैं तब यह पॉसिबल है क्या? चेक करो. हां जी, पॉसिबल है. वाई पॉसिबल है? बिकॉज मेरा जो कंडीशन दिया हुआ है वो कंडीशन क्या है? लेस देन इक्वल्स टू 0. लेस देन 0 नहीं हो रहा है, ये तो पता चल गया. चलिए, एक ही ऑप्शन मेरा पास बचा है कि ये पूरा एक्सप्रेशन को 0 बना दे. और 0 बनाने के लिए ln 2, ln 3, ln 4, ln n, ये तो कभी 0 नहीं होगा. सो 0 होने का एक ही तरीका है, ये जो इसका कोफिशिएंट्स है, ऑल दिस ln का जो कोफिशिएंट्स है, ये खुद ब खुद 0 बन जाए. और ये बिल्कुल 0 बन रहा है अकॉर्डिंग टू इन द गिवन रीजन. ओके, तो इन लोगों को सबको एक होना पड़ेगा. मतलब 1/sin² xi, it has to be equals to 1 to make that expression equals to 0. ओके, इसका मतलब मुझे हुआ क्या? देखो बच्चों, यहां पर मेरा जो हुआ वो है कि मेरा जो sin² x2 है, sin² x3 है, sin² x4 है, इसको अगर 0 बनाना है तो ये हर एक टर्म को मुझे 1 बनाना पड़ेगा. और बच्चों जब xi लाई कर रहे हैं, जब xi यहां पर लाई कर रहे हैं, देखो 0 से 2 पाई के अंदर, राइट, 0 से 2 पाई के अंदर, सो साइन स्क्वायर xi लाई कर रहे हैं 0 से 1 के अंदर, करेक्ट। अगर वही है तब ये x2 x3 x4 xn क्या वैल्यू ले सकता है? Okay, now let me just erase this portion so that we can understand it better. एक मिनट। अभी बच्चों मुझे देखना है कि ये जो एक आ रहा है, 1 आ रहा है, मेरा इस रेंज पे कहां पर ये सबका वैल्यू 1 आ रहा है, राइट? मेरा रेंज क्या है? ऑलवेज रिमेंबर, एक साई मेरा दिया हुआ है, इट इज लाइंग फ्रॉम 0 से 2 पाई के अंदर, ओके? अभी साइन स्क्वायर एक्स का ग्राफ कैसे बनेगा? साइन स्क्वायर एक्स का ग्राफ बनेगा कैसे? ऐसे बनेगा, ओके? ये मेरा साइन स्क्वायर एक्स का ग्राफ है, ये साइन स्क्वायर एक्स का ग्राफ है। कितना दूर तक हमने ड्रॉ किया? हमने ड्रॉ किया 0, ये, दिस इज पाई एंड दिस इज 2 पाई, ओके? अभी देखते हैं कहां पर ये साइन स्क्वायर x2, साइन स्क्वायर x3, साइन स्क्वायर x4, ये सब 1 हो रहा है। क्लियरली वी कैन सी एट दिस पॉइंट एंड एट दिस पॉइंट। ये पॉइंट मेरा क्या है? ये पॉइंट है मेरा π/2, और ये पॉइंट क्या है? ये पॉइंट है मेरा 3π/2। मतलब ये मेरा जो xi है, ये अगर π/2 लेते हैं या 3π/2 लेते हैं, इन दोनों केस में माय कंडीशन इज फुलफिल्ड। क्लियर हुआ? अभी x2 x3 x4 xn कितना वे से ये दोनों वैल्यूज ले सकता है? दैट विल बी अवर सोल्यूशन, मतलब टोटल नंबर ऑफ सॉल्यूशंस विल बी दैट। अभी देखो x2 के लिए मेरा कितना ऑप्शंस खुला है? 2 ऑप्शंस। x2 π/2 भी ले सकता है, 3π/2 भी ले सकता है, मतलब इसका है 2 वेज, 2 वेज। सिमिलरली x3 का भी 2 वेज है, ये π/2 भी ले सकता है, 3π/2 भी ले सकता है। सिमिलरली x4 का भी 2 वेज, सिमिलरली xn का भी 2 वेज, राइट? मतलब टोटल कॉम्बिनेशन ऑफ द सॉल्यूशंस विल बी 2 into 2 into 2 into how many times? n minus 1 times. बिकॉज हर एक वैल्यू, x2 बोलो, x3 बोलो, x4 बोलो, कुछ भी बोलो, ये 2 तरीके से वैल्यू ले सकता है। x2 भी ले सकता है, π/2 भी ले सकता है, 3π/2 भी ले सकता है। तो हर एक वैल्यू के लिए x2 x3 xn तक एक एक का 2 तरीका है टू टेक द वैल्यूज, एंड विच इज गोइंग टू सैटिस्फाई दिस inequality. So the total number of solutions will be 2 to the power n minus 1. Total number of solutions will be 2 to the power n minus 1. अगर ये solution समझ में नहीं आया, please write down in the comment. I will definitely answer your question. But what I will suggest you, after seeing this solution, you try this sum by your own. There also you will face some problem, and try to cover those problems by your own. If you cannot do, then again see the solution. 2-3 times if you see the solution, everything will be understand. Okay. In this question, let us say root of pi is a. So we are having a to the power so we can write this thing as I have simply applied the properties of logarithm. So we can write so the whole thing within the bracket is an infinite GP. So I am applying the formula for the sum of infinite GP, that is A divided by 1 minus R. So that gives us A is basically root of pi. So I'm substituting the value. So it will be pi to the power half whole to the power. So 2 goes off. So we are left with pi to the power log x base pi. Hence the answer is x.
Thus x equals to 3. Therefore, option C is correct.
Okay, let us move for the next one. The second question is A0 is 0 and AN is, this relation is given and it has been said that N is greater than equals to 1. So we have to find out the remainder obtained when A suffix 2010 is divided by 11. Now in place of N, if I put, let us say 1. So what we are getting? A1 is, A0 is 0, so A1 is coming to 1. Now if I put N is 2, so we are having A1 is 1, so it's like 3 plus 1, okay? Now if I put N is 3, what we are getting? We are having, now A2 is 3 plus 1, so I am replacing that. So if I open the bracket, it's 3 square plus 3 plus 1, right? Now, what will be A4? In place of N, I am putting 4. So we are getting A3 can be written as, so we are having, okay. So have you observed this? A base 4, I mean A suffix 4 is ending with 3q. So obviously, if it is A2010, if we move on doing this, we are going to have something like this. Isn't it so? It is always 1 less than the number given in the suffix. Now it is it's a GP. Total number of terms are 2010. So the sum will be, so we are having 2 times A 2010 is 3 to the power 2010 minus 1, right? Now, the question is when A2010 is divided by 11, what is the remainder? Now, here I am applying Fermat's little p, where p is prime, and GCD of A and P is 1. That is, A and P are co-prime. Okay. Then Fermat's little theorem states that A to the power P minus 1 and 1 is congruence modulo P. So in this case, we can observe that 3 and 11, they are co-prime numbers and 11 is a prime number. So we can say 3 to the power 11 minus 1 is 1 modulo 11. So 3 to the power 10 is basically 1 modulo 11, right? Now what do you mean by that? Now when 3 to the power 10 is divided by 11, when 3 to the power 10 is divided by 11, the remainder is 1. So, if I raise the power to 3 to the power whole to the power 201, so again the remainder remains the same. So 3 to the power 2010 when divided by 11, the remainder is 1. Is it clear? The remainder is 1. Okay, so 3 to the power 2010 minus 1 is completely divisible, by 11. Okay, it is completely divisible by 11. Therefore, 2 times A2010 is completely divisible by 11, and as 11 is a prime number, so we will say that A2010 is definitely a multiple of 11. Multiple of 11. Is it clear? Therefore, the remainder is nothing but 0. Hence, option A is correct for this problem. Now, in this question, we have to find out the sum till 50 terms. So, the nth term of the given series is, now if I separate, now I'm writing n square as so here what excess we have written. Here is actually n square factorial n we are getting. So here we have added 3n factorial n. So I have to subtract that. And at the same time we have added 2 factorial n, which is again to be subtracted. So we are getting now this 4n factorial n can be written as n plus 1 minus 1. I have manipulated this n in the way n plus 1 minus 1. So it is n plus 2 factorial n, n plus 2 factorial minus 4 times so we are getting Tn as right. Now I'm putting n equals to 1, 2, 3, 4 till 50. So what we are getting? So for 2 we are having, for 3 we are having, similarly T4 will give us and this thing goes on, right? So what is our T49? And T50 will give us now if I add the corresponding sides we are going to have, in the left hand side we are going to have S50, and in the right hand side, see this one, if I add it, this part will get cancelled. Root factorial 3 minus 4 factorial 3 plus 3 factorial 3. Again, similarly 4 will go off and this thing goes on. Similarly, this will be cancelled with the previous term, which is here, with this one. Okay? And then again, this part will be definitely get cancelled with the previous 2 terms, right? So we will be left with This one, if I simplify, we are going to have minus 8 plus 3 plus 6. And here we can write 52 into 51 factorial minus 3 times 51 factorial plus 1. So we are getting here, if I take 51 factorial common, so 49 into, hence option B is correct for this problem. Okay. This is question number 4. We have been given x1 is half and the relation is xk plus 1 is xk square plus xk. So now we can write this thing as I'm writing the left hand in the right hand side in this way. Okay. So if I take this part in the left hand side and this part in the right hand side, we are having okay. So this relation we got. Now let me put k equals to 1, 2, 3 till 100. What we are getting? And this thing goes on. So the last term, when we put k equals to 100, we are going to have Is it clear to all? Now, if I add the corresponding sides, in the left hand side, we are going to give, we will get the given expression. And in the right hand side, if you observe, we will find that this, again, these terms will get cancelled. So ultimately, we will be left with 1 over x1 minus 1 over x suffix 101. Now, we have been already given that x1 is half. Therefore, 1 by x1 will give us 2 minus 1 over x suffix 101. Now, we have to find out the greatest integer value for this expression. Now, we can easily see from the given relation that we are having xk plus 1 is xk square plus xk. Now, if I put k equals to 1, we are going to have x2 as x1 square plus x1. So that gives us, x1 is basically half, so this one will give us 1 over 4 plus 1 over 2. So that gives us 3 over 4, right? Now if I put x3, we are going to have, in place of k, I am putting 2. So we are having x3 equals to x2 square plus x2. Now x2 is 3 over 4. So this gives us So this is basically, if we simplify, we are going to have 9 plus 21 over 16, right? 21 over 16. So we can easily see that 1 over x3, as this is greater than 1, so 1 over x3 will be less than 1, right? Similarly, if we move on, if we go for x4, x5 and so on, these all values will be more than 1. Eventually, when we reach x suffix 101, this will be also greater than 1. So 1 over x 101, this will be less than 1. If it is less than 1, then this expression, this part will become what? This part will become 2 minus some fractional value. Some fractional value. And if it is a fractional value, then this value will be little less than 2. Therefore, if we take the greatest integer function of this function, then we are having the greatest integer value of this function. Now, 2 minus some fraction, it will be 1 point something. Therefore, its value will be 1. And that will be our answer for this problem. Hence, option D is correct. So, for this problem, your option D is correct. Is it clear? Okay. Now, so this problem. In this question, they have said that alpha, beta are the two roots. Alpha, beta are the two roots of this given equation. X square minus 36x plus lambda equals to 0. So therefore, we can write that alpha plus beta is 36 and alpha beta is lambda. Now, we have to assume the minimum value of lambda and we have to find out the value of the given expression. That is root alpha plus 2, root beta plus 2 divided by mod of alpha minus beta. So, lambda assumes the minimum possible value. So, for that, what I am doing, we are having lambda equals to alpha beta and beta is replaced by 36 minus alpha, which is coming from this relation. So, we are basically having 36 alpha minus alpha square. Alpha square minus 2 into 18 alpha plus, let me just add 18 square. So, I have subtracted 18 square, so I have added 18 square over here. 18 square is 324 minus this is alpha minus 18 whole square, right? So, if lambda will take the minimum value, if it takes the minimum value, so obviously alpha minus 18 should take the maximum value. Okay? Now, when it will take the maximum value? It will take the maximum value as we are having alpha plus beta is 36. So, the maximum value that alpha can take is 36. It cannot exceed 36. Now, if I take alpha as 36, then beta comes to 0. And as they have said that alpha and beta all belongs to natural number. Therefore, your beta cannot take the value 0, right? So, to make it maximum, we cannot take alpha as 36. So, the next value we will take, that is alpha is 35. If alpha is 35, your beta gives us 1, okay? Because alpha plus beta is 36. Now, your lambda becomes what? Lambda becomes 35 into 1, that gives us 35. But there is another condition given that lambda over 5 does not belongs to any integer. But if lambda is 35, then lambda over 5 gives us 7, which is an integer. So, this value also we will not take. So, we will take the next one, that is alpha is 34. If alpha is 34, then beta comes to 2, because alpha plus beta is 36. Now, in that case, your lambda gives us 34 into 2, that is your 68. And this 68, when divided by 5, does not belongs to an integer, right? So, to assume that lambda is taking the minimum value, we have to take the maximum value of alpha minus 18 whole square, and eventually we are getting that your alpha will take in that case 34 and beta will take 2. Therefore, the required value of the given expression, which is alpha plus 2 into beta plus 2 divided by mod of alpha minus beta, is basically root 36 into root 4 divided by modulus of 34 minus 2. So we are getting 6 into 2 divided by 32. Now if I cancel, so we are getting the answer as 3 over 8. Therefore, the value of this expression is 3 over 8. Hence, option A is correct. Okay. The next question. Question number 6. If we observe the three relations which is given to us, we can easily see that the equation this equation will have three roots, A, B, and C. So if we try to simplify this, we are going to have which is equals to x times x minus 1, x minus 2. Okay? Now, this equation, it has three roots, A, B, C. Now, they have asked for to find out the value of A into B into C. That is, they want to find out the product of three roots. And we all know it's a cubic equation, right? It's a cubic equation. So, we know that for a cubic equation like this, the product of three roots will be, if the roots are, say, alpha, beta, and gamma, so we will say alpha, beta, gamma will be minus of d over a. Okay. So in this case, in this particular relation that we got, here we have to find out what is the coefficient of x cube, which is clearly from this equation, we are going to have x cube from this expression, and the coefficient will be 1. And we have to find out what is the constant term for this cubic equation. And the constant term will obviously come from this part, which is nothing but your only 2. Isn't it so? It's 2 because constant will come from here. No constant will come from here or from here. So when we take everything in the right hand side, you are going to have that constant term as minus of 2. Right? Everything in terms of when we converted everything in, when I have shifted everything in the right hand side, you are getting the constant term as minus 2. Therefore, the product of three roots will be minus of minus 2 divided by 1, as the coefficient of x cube is 1. Hence, the answer will be 2. Therefore, the value of ABC is nothing but 2. Hence, option B is correct. Okay, the next problem. So in question number 7, we have been given that Px is x to the power 6 minus x to the power 5 and Qx is, and they have said that alpha, beta, gamma, delta are the roots of Qx equals to 0. So what I'm trying to do, I'm simply dividing Px by Qx. So how we can write that? Just normal division. And if we subtract, we are having this. Okay. So now plus 1 will give us, and if we again subtract, we are going to have x squared minus x plus 1. Therefore, your Px can be written as quotient into Qx plus the remainder. This is the easiest way of doing this sum. Now, we have been said to find out the values of P alpha plus P beta plus P gamma plus P del. Therefore, your P alpha will be this part. If you put alpha, beta, gamma or del, every time it will become 0. Why? Because if I put alpha, then this part will give us Q of alpha. And since alpha is a root of Qx, therefore Q of alpha will become 0. So it is same as for beta, gamma as well as del. So P alpha will be only this thing, right? Because the first part will become 0. Similarly, what will be P beta? Similarly, P gamma and P delta. Okay. Now, we have been said to add this 4. So, we are having which is equals to plus 4. Okay. Now, you see alpha, beta, gamma, del are the roots of Qx equals to 0. That is, so sum of all the roots will be, we can write this thing as sigma alpha also. This is the way of writing. So it is nothing but your 1. And sigma of alpha beta will be minus 1. Okay. So now if I square the first relation we are having, this is 1. So that gives us actually and we need to find out this. Let me just denote this thing as S. And sigma of alpha beta is minus 1. So we are having S as nothing but 1 plus 2 gives us 3. Therefore, the value of this expression is nothing but 3. The value of this expression, as we all got from number 1, it's 1. And this is 4. So, the answer will be 3 minus 1 plus 4, which gives us 6. Hence, option B is correct for this problem. Is it clear? This is our next problem, number 8. The question is, alpha, beta, gamma are the acute angles and we have cos theta as sin beta by sin alpha, cos phi as sin gamma by sin alpha. And the second relation that is given to us is cos theta plus phi is sin beta sin gamma. Okay, and we have to find out the value of tan square alpha minus tan square beta minus tan square gamma. So we can easily see that the value that we need does not contain any theta and phi. So all we have to do is we have to remove this theta and phi from this relation. From this relation, let us denote this thing as relation number 1. From this relation, if we can remove theta and phi, definitely we are going to have a relationship between alpha, beta and gamma. So this can be written as let me first take sin theta sin phi in the right hand side. And let me replace cos theta by and cos phi by, right? So let me take sin beta sin gamma common. So we are having So it's sine beta sine gamma into cos square alpha over sine square alpha. Is it clear? From here we can write sine square alpha as divided by sine theta sine phi. Again, you see in the denominator we are having sine theta sine phi. That has to be removed. That is, you have to convert that thing in terms of beta and gamma so that we will get a relationship between alpha, beta and gamma. Otherwise, we will not get it because theta and phi is an unnecessary element in our problem. So, but we cannot replace sine theta and sine phi because we don't have any direct relation of sine theta and sine phi. But we are having the relationship with beta and gamma with your cos theta cos phi, right? So I have to convert the thing in terms of cos theta and cos phi, and for that I am squaring both sides. In the denominator we will have sine square theta sine square phi. Sine square theta can be written as 1 minus cos square theta. Similarly, 1 minus sine square phi. Now, cos theta we know that we are having basically 1 minus cos square theta. I will replace this thing by, and sine square phi I will replace this thing by, I'm sorry, this thing will be cos square phi. I'm sorry, this thing will be cos square phi. So cos phi will be replaced by sine gamma by sine alpha. So it will be sine square gamma by sine square alpha. So after simplifying, we are going to have sine to the power 4 alpha in the numerator divided by sine square alpha minus sine square beta into sine square alpha minus sine square gamma, right? Which is your sine to the power 4 alpha. And we can cancel this thing from both sides. So if we cross multiply, we are going to have sine square alpha minus sine square beta. And in the right hand side, we are having, okay. So now let me just multiply this. Sine to the power 4 alpha minus and in the right hand side we are having sine square beta sine square gamma, and this is cos to the power 4 alpha, which can be written as cos square alpha whole square, and cos square alpha can be written as 1 minus sine square alpha whole square. Now if you open this, sine square beta, sine square gamma, this goes off from the both sides, and you can easily see that we are having sine square alpha common. So let me just cancel from both sides. So we are having sine square alpha. If I remove from both sides, that is, I am dividing both sides by sine square alpha, we are getting this thing we got. Now let me take this thing in the left hand side. So we are having in the right hand side we are having sine square beta plus sine square gamma minus 2 sine square beta sine square gamma. So actually we are having sine square alpha is basically sine square beta plus sine square gamma minus 2 sine square beta sine square gamma divided by 1 minus sine square beta sine square gamma. So if this is your sine square alpha, so what will be your cos square alpha? 1 minus sine square alpha. So that gives us 1 minus this whole thing. And if we simplify, we are going to have so the numerator after simplification, this one and this one we can simplify. So now if we just factorize this, so we are having 1 minus sine square beta, 1 minus sine square gamma divided by 1 minus sine square beta sine square gamma. So that is basically cos square beta into cos square gamma divided by 1 minus sine square beta sine square gamma. Is it clear? This sum is pretty lengthy sum. It's true. This is the only sum given in this paper which is little lengthy. So we got this value is basically your cos square alpha. This is your cos square alpha. And what about your sine square alpha that we got? We got this thing as our sine square alpha. Right? This is your sine square alpha. Now, if I divide this two, we are going to have tan square alpha, which is your sine square beta plus sine square gamma, sine square beta plus sine square gamma, minus 2 sine square beta sine square gamma divided by cos square beta cos square gamma. That's it. Now let me do one thing. I'm taking sine square beta common, so it will be 1 minus this 2 sine square beta sine square gamma. I'm writing it as sine square beta sine square gamma minus sine square beta sine square gamma. And if I take sine square beta common, we are left with 1 minus sine square gamma. And from the second one, if I take sine square gamma common, we are having divided by cos square beta cos square gamma. So this is basically sine square beta cos square gamma plus sine square gamma cos square beta divided by cos square beta cos square gamma. Now if we separate, we are going to have sine square beta cos square gamma divided by cos square beta cos square gamma will give us tan square beta. And for the second one, this one when divided by cos square beta cos square gamma, it will give us tan square gamma. From here we can write tan square alpha minus tan square beta minus tan square gamma is basically 0. Hence option B is correct for this sum. This sum is pretty lengthy sum. So try this sum for several times so that you will be comfortable with this kind of problems which may come in the future days. Okay, let us move for the next problem. So in this question, before starting the sum, we have to first define the function, define the inequality which is given to us. So first of all, to define this log, 1 over x has to be greater than 0 implies your x has to be greater than 0 and at the same time, x cannot be equals to 1. And which is inside the log has to be greater than 0. So the critical points that we are getting is minus 1, 2 and 5. So your x will come here and here. Therefore, your x is lying between minus 1 and 2 or 5 less than x less than infinity. Okay? So combining this and this, we can say that your x is lying between, as x is greater than 0. So we will write that x belongs to 0 to 2 or from 5 to infinity, but be careful, you cannot take the value 1. Okay? So this is the values of x for which the given inequality or the logarithm is defined. Okay, so now to the actual problem. In the base of logarithm, we are having 1 over x. So we have to consider two cases. Case 1, we are assuming that your x is lying between 0 and 1. Okay, x is lying between 0 and 1. If x lies between 0 and 1, eventually your 1 over x is more than 1. Therefore, the given logarithm will become is greater than equals to 1 by x to the power 1. So that gives us 1 over x. So therefore, we can write so now if I take the LCM, so it is 2 times x minus 2 minus x plus 1, x minus 5 is greater than equals to 0. So from here we can write 2x square minus 4x minus x square plus 4x plus 5. So we are having in the numerator x square plus 5 because 4x goes off. X into x plus 1 into x minus 5 is greater than equals to 0. So this part x square plus 5, we all know that for all real values of x, this is always positive. Therefore, our critical points comes to be minus 1, 0 and 5. So plus minus plus minus. So your x will come here, x will come here. Or x is lying between minus 1 and 0 or it is more than 5. But you have assumed that your x is lying between 0 and 1. As x is lying between 0 and 1, so I'm sure that from this one, we are not getting any values of x. Moreover, one thing to be very careful, that is in the given definition, your x is more than 0, right? So under any circumstances, this part will never come. So the actual solution for this one will be x is more than 5. But we have already assumed for this case that x is lying from 0 to 1. Hence, from this, when x is lying between 0 and 1, we are getting no solution. We are getting no solution. Okay, now let me consider case 2. In this case, we will assume that your x is greater than 1. Okay, now if x is greater than 1, then eventually your 1 over x will be less than 1. So, we are going to have the same thing. Only thing is that this sign will get changed. That is, we are going to have something like this. Less than equals to 1 over x. So, after simplification, we will have exactly the same thing that we got it here. We got here. The same expression we will get. because there is no change in values, but this is less than equals to 0. So in that case, what we will do, we will take the, we will draw the number line, exactly the same number line we are going to have, but here we are going to take the negative region. Therefore, we will say that your x is lying from 0 to 5. Okay, x is lying between 0 to 5 because there is no point of taking any value which is less than -1 as your x is greater than 0. And in case 2, we have already taken that x is greater than 1. So there is no question of taking that region. So x will be greater than 0, less than 5. So now if we take the intersection of this one and this one, we can easily see that your x, as well as we must remember that x is greater than 1 here. So the intersection portion that will come is x is greater than 1 and less than 2. That's it. Okay. So this is the solution for our second case. But unfortunately, as they have asked for the number of integers that we are getting from this inequality, and between 1 and 2, there is no integers. Hence, there will be 0 integers for this case, which is going to satisfy, because there is no integer lying between 1 and 2. Hence, there is no integral values of x for which this given inequality is satisfied. Hence, my answer in this case will be 0. There is no integral values possible. Okay, so let us move for the next sum. This is our last sum for this weekly test. We have to find out the value of 3 times sigma. R is from 1 to 11 tan square r pi over 24. Okay. So for a time being, let us do one thing. Let me take pi over 24 be alpha. So we have to find out the value of tan square r alpha. Okay. That is, we have to find out the value of 3 times tan square alpha, tan square 2 alpha, tan square 3 alpha, tan square 4 alpha, and this thing goes on till tan square 11 alpha, right? Now, what we are trying to do, we are making 2 groups, because we can easily see that 2 alpha means it is coming like pi over 12, and pi over 12 is 15 degree. So we know the value of tan 15 degree. Similarly, we know the value of tan 30 degree and so on. Therefore, what we are trying to do, we are making 2 groups. The first group consists of the elements tan square alpha, tan square 3 alpha, tan square 5 alpha, 7 alpha, 9 alpha, and 11 alpha, right? And the second group consists of tan square 2 alpha, tan square 4 alpha, tan square 6 alpha, tan square 8 alpha, and tan square 10 alpha, right? Now, what is tan square 2 alpha? Tan square 2 alpha means I am doing it separately over here. What is tan square 2 alpha? Tan square 2 alpha is basically tan square pi over 12, which is tan square 15 degrees. And we know this value, it is 2 minus root 3. So that's squared. So it gives us, okay. Now, what about tan square 4 alpha? 4 alpha gives us tan square pi over 6, that is 1 over root 3 whole square. So tan square 6 alpha, that will give us tan square pi over 4, that gives us 1. Tan square 8 alpha means it's tan square 8 pi over 24. So it's tan square pi over 3. So that gives us root 3 square, which is only 3. Tan square 10 alpha, that gives us tan square 10 pi over 24. So that gives us tan square 5 pi over 12, which is your tan square 75 degree. That gives us cot square 15 degree, which is same as 1 over tan square 15 degree. And we all know that tan 15 degree is 2 minus root 3 whole square. That gives us 1 over 7 minus 4 root 3. So 7 plus 4 root 3, I'm simply rationalizing it. So 49 minus 48. So that gives us only 7 plus 4 root 3. Okay. So now, if I add all those terms, so we are going to have, from here we are having 7 minus 4 root 3. This one, 7 minus 4 root 3. Plus, this is 1/3. Plus 1 plus 3. And we are having plus 7 plus 4 root 3. So we are basically having 14. This goes off. Plus 1/3 plus 4. So we are having 55 over 3, right? So this part we are getting actually 55 over 3. So let it be in our hand. We will use it later on. Now let us just move for this part. We are having tan square alpha, tan square 3 alpha, tan square 5 alpha. Okay, where alpha is basically pi over 24. So now in this case, tan square 11 alpha is basically tan square 11 pi over 24, which can also be written as tan square pi by 2 minus pi over 24. So that gives us cot square pi over 24, which is simply cot square alpha, right? So this is basically cot square alpha. Similarly, if you check, you will find that tan square 9 alpha can be written as cot square 3 alpha, and tan square 7 alpha can be written as tan square 5 alpha. I'm sorry, cot square 5 alpha. I'm sorry. It's cot square 5 alpha, right? Cot square 5 alpha. Therefore, the given expression actually becomes tan square alpha plus cot square alpha, tan square 3 alpha plus cot square 3 alpha, and tan square 5 alpha plus cot square 5 alpha. So if I use a formula of a square plus b square, we are having a plus b whole square minus 2ab. Same thing for here. Same thing for here. So this thing is coming like, if we break it in sine and cos, we are going to have 1 over sine alpha cos alpha whole square. Similarly, in this case also, 1 over Sine 3 alpha cos 3 alpha whole square. Same thing here, 1 over sine 5 alpha cos 5 alpha whole square, right? And minus 6 is there. So if we multiply with the 2, here if we write 2, and if we give a 2 over here, so we are basically getting 4 over sine square 2 alpha, sine square 6 alpha, sine square 10 alpha minus 6. Now, what is 2 alpha? We all know that alpha is pi over 24. So, sine 2 alpha will actually give us sine pi over 12, which is your sine 15 degree. And sine 15 degree is root 3 minus 1 by 2 root 2. So, sine square 2 alpha will be root 3 minus 1 whole square whole by 8, right? Similarly, sine square 6 alpha will give us sine square 6 pi over 24. That is sine square pi over 4. So that gives us 1 over 2. Okay? And for sine square 10 alpha, we are going to have sine square 10 pi over 24. It means sine square 5 pi over 12. So this is basically sine square 75 degree, which is same as your cos square 15 degree. Therefore, this sum will be 4 over sine square 2 alpha, sine square 2 alpha plus 4 over sine square 6 alpha, right? Sine square 6 alpha plus 4 over, we are having sine square 10 alpha, right? Sine square 10 alpha minus 6. So, we got sine square 2 alpha as, if we break it, we are actually having 4 minus 2 root 3 over 8, right? So, and we can cancel also. We can write this thing as 2 minus root 3 over 4. Okay? So, if I put it here, we are going to have 4 over sine square 2 alpha. I am replacing by 2 minus root 3 over 4. So, 4 will go up. 2 minus root 3 in the denominator. Plus, sine square 6 alpha is basically half. So, it will become 4 over half. Plus, and in this case, we are getting, if we open this one, sine square 10 alpha, we are going to have 4 plus 2 root 3 divided by 8. And if we cancel by 2, we are going to have 2 plus root 3 over 4. So let me just replace this. So again 4 into 4, and in the denominator we will have 2 plus root 3 minus 6. So this is 16, and 2 plus root 3, if I rationalize, this is actually 8 minus 6 will give us plus 2. This is again, if we rationalize, 2 minus root 3 divided by, if we rationalize this one, we are going to have 1 in the denominator. So ultimately, we are going to have 32 plus 16 root 3 plus 2 plus 32 minus 16 root 3. So this and this goes off. So we are left with 32 plus 32 is 64 plus 2 is 66, right? So for the first one, what we got, let me change the color of the pen. So for the first one we got, for, where it is, for the first one, this one, for this one, just now we got the value of it is 64, right? So this is basically, I'm writing it here. So it's basically 3 times, we are getting 64, right? If I'm not wrong, it's 66, I'm sorry. So we are getting this thing as 66. This is 66 plus the second part, that is this part, we got the result as 55 over 3. So this one is 55 over 3, right? Now if I open the bracket, it is 66 into 3 is 198 plus 55. So if we add, so 253 is the correct answer for this problem. Therefore, question number 10, the answer is 253. For question number 10, the answer is 253. That is the correct answer. Is it clear to all? See the first question. They have said that A, B, C are the three roots of the equation. Therefore, we can write the sum of all the roots. The sum of the roots taken two together and the product of three roots is. Now, we are squaring both sides of equation 1 because these values will be needed while evaluating the given expression. Now the value of AB plus BC plus CA is 2. So we got A square plus B square plus C square is 1 minus 4, which is actually minus 3. This value will be needed. That is why I have calculated it in beforehand. Right? Now, let me square both sides of the second condition. Now let me take ABC common. Therefore, this value will become 4 minus 2 times ABC. The value of ABC is 3 and A plus B plus C is 1. Therefore, we are getting. So we got. These two values will be needed. That is why I have calculated it beforehand. Okay. Now we have to find out the value of the given expression. Now, what I'm trying to do is, I am not taking the modulus sign. I am simply calculating the given expression. And at last, I will take the modulus sign. We are having the expression like. So let me just multiply this with A. This one with B. And this one with C. And as we got that ABC is 3, we got ABC as 3. Let me replace it. Right? Now let me take LCM. So now let me consider the numerator only. I am simplifying the numerator only. So if I open the brackets, we are going to have Okay. So now if I open the brackets, we are going to have this one. Now, let me just replace the values that right now we have got. We have got the values of a square plus b square plus c square is minus 3. ABC is 3. And a square b square plus b square c square plus c square a square is minus 2. Thus we get the result as 27 goes off. So it's only minus 12. So the numerator is coming to minus 12. Now let us try to simplify the denominator that we have, which is so this can be written as so let me simply replace those values. A square b square plus b square c square plus c square a square is minus 2. And a square plus b square plus c square is coming to minus 3. So we are having the denominator as 3 only because 27 goes off, right? Therefore, the given expression, this expression becomes with a mod sign minus 12 over 3, that is modulus of minus 4, that is 4. Hence option D is correct. Is it clear? Okay. Now the second question. Now in the left hand side, let me just make a group of sine 6 degree, okay? So I made a group of sine 6 degree, sine 54 degree and sine 66 degree. Why I have done so, I will tell you. Into sine 14, sine 46, sine 74 degree. This is another group. And the third group will be sine 26, sine 34 degree and sine 86 degree, right? Which is equals to 1 over a sine 54 degree. Now, we know a formula, rather I should say a relation, that sine theta sine 60 degree minus theta sine 60 degree plus theta is always equals to 1 over 4 sine 3 theta. This formula or this result I will use here to simplify my given expression. So the left hand side will become sine 6 sine 54 sine 66 degree can be written as 1 over 4 sine 3 theta. Similarly for the second one, 1 by 4 sine 3 theta. Similarly for the third one, three into 26 degree. And in the right hand side, we are having 1 by a sine 54 degrees, right? Now, this all cancels. Now we are having sine 18, sine 42, sine 78 degrees, which is equals to 1 over a sine 54 degrees. Again, we are having the same formula we can use here. This relation we can use here because it is sine theta, sine 60 minus 18 degree, which gives us 42 degree. Sine 60 plus 18 degree gives us sine 78 degree. So we can write this thing as 1 over 4 sine 3 theta, means 3 into 18 degrees. This is sine 54 degrees, 1 over a sine 54 degrees. So comparing, we can get a is 4. We are getting a as 4. Hence, option D is correct. Is it clear? Okay, let us move for the third one. A and B are the maximum and minimum values of the given function. Now, I am rewriting the function. We have been given now we have to find out the maximum and minimum value of this function, which are represented by A and B respectively. So let us find out the extreme values for this function. So for that, what I'm doing, cos square x can be written as 1 minus sine square x. So we are having now we can write this thing as okay. So let me just separate. So we are having okay. So our fx comes to, let me just make it a sum of two squares. So it will be sine x minus 2 whole square plus 1. Now, to get the maximum value of fx, this expression has to be minimum. If fx is maximum, then the expression which is in the denominator should be minimum. And the minimum value will occur when sin x equals to 1. Therefore, the maximum value, which is denoted by A, is 1 plus 10 over 1 square plus 1. So that gives us 1 plus 10 over 2, that is 6. And this is the maximum value of the given expression. Now, what will be the minimum value of fx? Fx will be minimum when this expression is maximum. And the maximum occurs when sin x comes to minus 1. Therefore, the minimum value of the function fx is, which is your b, is 1 plus 10 over, because minus 1 minus 2 whole square, that gives us 9. 9 plus 1 is 10. So it's 1 plus 10 over 10. That gives us 2. Therefore, the maximum value is 6 and the minimum value is 2. Now, what they have said, their question is, what is the value of 2 times So let me just simply put the values. B is 2, A is 6. So in this case also, the option is D. I hope it is clear to all of you. Let us move for the next problem. We have been said that x minus a into x minus 3 is minus 1. It has all integral roots. Okay, so x has all integral roots. And a, they have also mentioned a belongs to integers. So we have to find out all the possible values of a and the product of all possible values of a. That is, in one word, we have to find out the values of a from this equation, where x will take integral values, a will also take integral values. So when the product of these two equals to minus 1, there are two cases which can happen. Case 1, when x minus a is 1 and x minus 3 is minus 1. And case 2 is when x minus a is minus 1 and x minus 3 is 1. So from case 1, what we are getting? From case 1, we are getting x as 2. So from there, we will get the value of a from the first one. That is, a equals to x minus 1 implies a is 2 minus 1, that is 1. So x can be 2 and a can be 1. This is one option or one solution. And case 2 is x is 4. And from the first one, we can write so the case 2 is x is 4 and a is 5. Is it clear? So the possible values of a are, how many possible values of a are there? 2. So there are 2 possible values. Now what they want is the difference of 3 times the number of possible values of a. 3 times the number of possible values of a, which is 2 in this case, minus the product of all possible values of a. Now, the values of a is 1 and 5. These are the possible values of a. Therefore, the product will be 5. So, our answer in this case will be 1. Hence, option A is correct. Is it clear? Okay. Let us move for the next problem. Next problem, we are having a matrix match. So let me take the first one. Tan 16, tan 42, tan 44. Tan 45 I'm not writing because tan 45 degree is 1, so it will go off. So tan 76 degree. So again we have a relation . Tan theta tan 60 minus theta into tan 60 plus theta is always equals to tan 3 theta. So in this case, if we observe, we will find that tan 16, tan 44 and tan 76, these 3 terms are falling in this category. Okay, so we are having what? Tan 3 into 16 degree into tan 42 degrees. Is it clear to all? So we are having tan 48 degree into tan 42 degree, which can also be written as, because 48 and 42, they are complementary to each other. Tan 90 minus theta is cot theta, so it is cot 48 degree. Tan 48 into cot 48 is 1. Hence, for 1, the matching in column 2 will be S. Okay, let me take the second one. So 1 minus cot pi over 10 into 1 minus cot 3 pi over 20. Now, pi over 10 is 18 degree. And 3 pi over 20 degree is basically cot 27 degree. Now, let me just multiply. So now, if we make a bracket, we make a group of and let me just convert everything in terms of sine and cos we are getting. So we are having this is sine A cos B plus cos A sine B. So it will be sine A plus B, which gives us sine 45 degrees. Now, observe one thing. Cos 18 degree, cos 27 degree. How can we write that? Let me just do it here. Cos 18 degree plus 27 degree. This is actually cos 45 degrees, which can be written as so cos 18 cos 27 degree can be written as cos 45 plus sine 18 sine 27 degree, right? Now, if I divide both sides by sine 18 sine 27, so we are having sine 18 sine 27. So, in the right hand side, we are getting cos 45 plus 1. Is it clear? Now, cos 45 degree is basically 1 over root 2. So, 1 over root 2 sine 18 sine 27 plus 1. Right? So, I will replace this part. I will replace this part by this one. So, we are having 2 plus 1 by root 2 sine 18 sine 27 degree minus sine 45 degree is 1 over root 2. Along with that, sine 18 sine 27 is in the denominator, right? So this and this will be cancelled. So we are left with 2. Therefore, the value of the given expression in 2 is nothing but 2. So 2 will be linked with R, right? It will be matched with the option R given. Now let us consider the third part. Now third part is a very interesting one. They have said pi, k is from 1 to 15, sine k pi over 10. Now, if you observe carefully, you will find that in place of k, I will put 1, 2, 3, 4 and all are multiplied because pi is there. So it will be like sine pi over 10 into sine 2 pi over 10 into sine 3 pi over 10. And this thing will go on. And the last term will be sine 15 pi over 10. Correct? But there is one term in between which is sine 10 pi over 10. Isn't it so? Now 10 pi over 10 is basically sine pi and sine pi is 0. So this whole product will become 0 straight away. No calculation involved in it. Therefore, 3 will be linked with P. Okay, and we are left with the last one, that is number 4 for this column matching type, plus cos 65 cos 55 degree, right? So let me take half common. So it will be 2 cos square 65, 2 cos square 55, 2 cos 65 cos 55, right? Now, 2 cos square theta can be written as 1 plus cos 2 theta. Similarly for this one also. And this one is 2 cos A cos B. So cos A plus B. So this is 2. Cos 120 degrees minus half. And we are left with cos 130, cos 110 and cos 10 degree. So this thing will give us half 3 over 2 plus this part. Okay. So this will give us. Now let me apply the formula cos C plus cos D for these two terms. We are having 2 cos C plus D by 2, cos C minus D by 2, plus cos 10 degrees there. So this is 2 cos and we all know that cos 120 degrees minus half. So it will be 2 times minus half cos 10 degree plus cos 10 degree. So this 2 and 2 will go off. So it's half minus cos 10 plus cos 10. So this one will give us 3 over 4 because this 2 will be cancelled, right? So your part 4 will be mapped with, it will be mapped with Q. Okay? Now, let us move for the next problem. This is our integer type problem. In this question, f of 1x is given mod of mod x minus 2 and the relation which is given is fn x is modulus of fn minus 1x minus 2 for all n greater than equals to 2, n belongs to any natural number. Now they have asked for how many number of real solutions are there for this function. That is, we have to draw the graph of two functions here. One is f suffix 2015x and we have to draw the graph of y equals to 2. Y equals to 2 is basically the line which is parallel to the x-axis and the number of points where it is intersecting the curve will be the number of solutions for this equation, right? Now, to find out f suffix 2015x, how the curve will look like, let me just draw the graph of f1x. We will simply use some graphical transformation. One is y equals to mod x. The graph looks like this. Mod of x minus 2, so it will come down by 2 units along the y-axis. So the curve will look something like this. This is your 0, minus 2. Now, this is the graph of mod x minus 2. Now, the graph of mod x minus 2 will look something like this. This point is 0, 2. Now, if x equals to 2, if I draw the graph y equals to 2, we can easily see, let me change the color of the pen. Y is equals to 2 is this line, and we can easily see that it is intersecting the curve at 3 points, right? So, if x equals to 2, we are having 3 solutions, right? Now, let us use the relation given to find out what is f2x. So, f2x will be modulus of f1x minus 2. Now, f1x is what? Modulus of mod x minus 2 minus 2. Now, the graph of modulus of x minus 2, this one is this graph, right? So, minus 2, again it will come down. This whole graph will come down by 2 units along the y-axis in the negative direction of the y-axis. So, the graph will look something like this. Right? Now, when you are taking, this is the graph of y is equals to modulus of mod x minus 2 minus 2. This is the graph of this. Now, to draw f2x, we have to put a mod sign outside. So now the graph will look something like this. Right? So this is the graph of y equals to f2x. Now, if I draw the line y equals to 2, we can easily see that it is intersecting the curve at 4 points. So, f2x equals to 2, we are having 4 solutions. For f1x, we got 3 solutions. For f1x, we got 3 solutions. For f1x equals to 2, we got 3 solutions. From f2x equals to 2, we got 4 solutions. Now, if you observe this pattern, you will find that when it is f1x, we are having 3 solutions. When it is f2x equals to 2, we are having 4 solutions. So, whatever may be the suffix, the number of solutions will be the suffix plus 2. So, it is 2017 number of solutions you will get when we draw the graph y equals to, when we draw the graph of y is equals to f2015x and y equals to 2. They are going to intersect each other at 2017 points. Hence, the total number of real solutions for this equation is 2017. So, 2017 number of real solutions are possible. So, for this question, the answer will be 2017. That's the answer. Okay. Now, let us move for the last sum of this test. We have been given x square minus x plus 2 equals to 0. We are having 2 roots alpha and beta. So, alpha plus beta is 1 and alpha beta is 2. Now we have to find out, let me just consider the numerator only first. We have to find out sigma n from 1 to 5 Sn. And your Sn is alpha to the power n plus beta to the power n. So in this case, we have to find out the value of S4 plus S5, right? This is all about your numerator. I haven't touched yet the denominator. I will do it later on after completing this. So for S1, if we consider the alpha and we write it in a bracket, so we are going to have alpha, alpha square, alpha cube, alpha 4, alpha 5. Same thing with beta. Beta plus beta square plus beta cube plus beta 4 plus beta 5, right? So let us just check what will be the answer for what is the value of this one. Because the answer for alpha will be exactly same for the beta also. Only thing is that here alpha is involved, there beta is involved. Nothing else is given more there. So how to solve this one? Let me take alpha square common from these two. So we are having 1 plus alpha square. And again you are taking alpha cube common. So we are having 1 plus alpha square. I have taken alpha cube common from alpha cube plus alpha to the power 5. So we are having alpha square plus alpha cube into 1 plus alpha square, right? Now, if I take alpha square common, we are having 1 plus alpha into 1 plus alpha square. Now, since alpha is a root of this equation, hence alpha square minus alpha plus 2 will be equals to 0. And alpha square plus 1 will be alpha minus 1. So I can replace this 1 plus alpha square by alpha minus 1. So we are having what? Alpha plus alpha square into alpha square minus 1. Again, alpha square minus 1, we are having alpha square minus alpha plus 2 is 0. So what is alpha square minus 1? It will be alpha minus 3. So let me just replace that. Alpha square minus 1, I am replacing it by alpha minus 3. And I am replacing alpha square by alpha minus 2. So what you are getting? Alpha plus alpha square minus 5 alpha plus 6. So we are having alpha square minus 4 alpha plus 6. Again, in place of alpha square, if I write alpha square is alpha minus 2, so simply replace that. It's alpha minus 2 minus 4 alpha plus 6, right? I have replaced alpha square by alpha minus 2. That's it. So we are getting minus 3 alpha plus 4. The same thing we will get in case of beta. In that case, we will get minus 3 beta plus 4. For this part, we will get minus 3 beta plus 4. So therefore, if we add these two, we are going to have minus 3 common. So it's alpha plus beta plus 8. And we all know that we have already said that alpha plus beta is 1. Therefore, it will be minus 3 into 1 plus 8, that gives us 5. Right? So for the numerator, we are getting the value 5. Now, for the denominator, we are having sigma n is from 1 to 4, alpha n, beta n plus 7. It means what? It actually means alpha plus alpha square plus alpha cube plus alpha 4. Same thing here, beta plus beta square plus beta cube plus beta 4. plus 7. Now, again from this, what I'm doing, from this 2, I'm taking alpha common. And from this 2, I'm taking alpha square common. Right? So, I'm not doing this beta thing because this beta thing will be exactly the same way as I'm doing with the alpha. So, whatever answer, whatever simplified version we will get for this alpha will be exactly same for your beta. So, I'm not doing beta anymore because it will be a, wastage of time. So, whatever beta will be there and plus 7. So, it's 1 plus alpha square into alpha plus alpha square plus the same thing with beta, that is 1 plus beta square, beta plus beta square plus 7. Okay. Now, again, alpha square plus 1. Here I have written your alpha square minus alpha plus 2 is 0. Therefore, alpha square plus 1 will be your alpha minus 1. So, let me just replace this with alpha minus 1, and if I take alpha common, we are having alpha plus 1. Same thing with beta, I'm not writing it. So, this is alpha into alpha square minus 1. Again, alpha square minus 1 can be written as minus alpha plus 3, which is 0. Therefore, alpha square minus 1 will be alpha minus 3. So, let me replace that again. Alpha minus 3. Same thing with beta plus 7. So, it's basically alpha square minus 3 alpha plus same thing with beta. It will give us beta square minus 3 beta plus 7. Now, what is alpha square? Again, we can replace this by alpha square is alpha minus 2. So, let me replace that. Alpha minus 2 minus 3 alpha. Same thing here. Beta minus 2 minus 3 beta plus 7. So, we are basically having minus 2 alpha minus 2 beta. This is minus 4. So, plus 3. So, if I take minus 2 common, so it is alpha plus beta plus 3, and alpha plus beta is 1. So, we will write minus 2 into 1 plus 3. So, your answer comes to 1 only, right? So, for the numerator, we are getting 5, and for the denominator, we are getting 1. Therefore, the given value will be, the numerator is 5 and the denominator will be 1. So, the answer will be 5 in this case. Is it clear? So, that is the option for question number 7. I hope you have understood this.